In this video, I'll show a brief introduction to Mininet and its use for exploring OpenFlow and SDN. Before we jump right in, let's look at a quick slide overview. So what is Mininet? Mininet is network emulation software that allows you to launch a virtual network with switches, hosts, and an SDN controller all with a single command. It's a great way to start learning about SDN and OpenFlow, as well as test SDN controllers and SDN applications. You can go to mininet.org for full details, installation instructions, to download a VM, for tutorials, FAQs, and to join the mailing list. Everything I show here is covered in the mininet.org walkthrough, so I highly recommend you take a look there. So let's jump right in. Here you can see I'm running a Mininet VM within VirtualBox. I'm doing this on my Linux Mint laptop. You can use Windows or Mac as well, as long as you have a virtualization application like VirtualBox or VMware. I'm not going to spend time reviewing the installation, but if you go to mininet.org, you can download a VM there and review the installation notes. Also, if you want to use VirtualBox, you can just go to virtualbox.org and download it from there. In the comments, I'll put a few notes from installation on my system that were useful to get SSH working, that you will see me do right now. Okay, so here we can see Mininet running in VirtualBox. All I'm going to do here is grab my VM's ETH0 IP address so I can SSH into it. So I'll log in here. The username is Mininet. The password is also Mininet. And here I'll just do an ifconfig. And I can see that my ETH0 IP address is 10.00.11. So I'm going to SSH into my Mininet VM, and I'm going to use the -x option. 10.0.0.11. The -x option will enable X11 forwarding. X11 forwarding will let me launch Wireshark and let me xterm into hosts in my Mininet topology, as we'll see in just a moment. So username is Mininet again, and the password Mininet again. So let's launch Mininet with the default minimal topology. This is very simple. I have the option of launching other topologies and specifying a particular SDN controller, but here we will just do the default. So I'm just going to run sudo mn. Very simple. So just like that, I have an emulated network with two hosts, an OpenFlow kernel switch, and a basic OpenFlow reference controller. These two hosts are using the network namespace feature of Linux, where even though I'm on a single VM, each of these pseudo hosts have their own network sockets isolated from each other. On this video, we can see the default minimal topology. We have our two hosts in their own network namespace. We see their ETH0 interfaces connect to the OpenFlow kernel switch. We also see the control channel from the switch to the OpenFlow reference controller. Using a different command line option or using the Python API, you can build many more topologies than just this one, but this is just the default example. I like to think of this as an SDN network in a box, and it's launched with a single command. So back to Mininet. So I'm at the Mininet prompt now, and let's take a look at some of the commands I have. Help. If I type help, I see the commands available to me. If you're like me, you always run into cases where there's some command you want to use and you can't quite remember the name of it, so help is very useful here. Nodes. So I'll type nodes, and I can see again the two hosts, H1 and H2, the controller C0, and the OpenFlow switch S1. Dump. Dump spits out more details about my network emulation setup in Mininet. Here again we see the hosts, H1 and H2, the controller, the OVS controller, C0, and the OVS switch, S1. Net. Typing net will show me the network links between devices. These are virtual Ethernet pairs between the hosts H1 and H2 and the switch S1. So see that H1's ETH0 again is connected to S1's ETH1, and H2's ETH0 connected to S1's ETH2. Now here are two ways I can issue commands for the hosts H1 and H2. The first is I can issue shell commands to a host right from the Mininet prompt. For example, I can say H1 ping H2. And we see that working. And it'll Control-C out of there. You'll see here that the first ping took longer than the other two. Remember, this is an SDN network using OpenFlow. For the first packet of any flows, the switch has to notify the SDN controller and wait for a reply on what actions to take with that packet. In another video, I'll review OpenFlow basics, But for now, you can see this extra latency on the first packet because of the communication with the controller. After that first ICMP request and reply, the flows are cached by the switch for a limited time, so the rest of the packets don't need to be checked with the SDN controller and don't have that extra latency that we saw. Okay, so another way I can interact with the host is to open Xterm windows. This is why we needed the -X option when I originally SSH'd into the Mininet VM. So I'll do Xterm H1. And here we see a shell for H1. Again, I can ping H2, but I have to use its IP. So I'll do a ping a count of 3, 10.0.0.2, and we see that working just fine. We can enter pretty much any shell command, so I'll also do an ifconfig, and I see my IP address 10.0.0.1 as we expected. We can also do a TCP dump. I'll say no, don't do name resolution. And to generate some packets, again I'll do H1 ping H2. We see some pings working here, and in my Xterm window I can see TCP dump working just fine, so I can analyze some packets this way. Let me break this and exit out and kill the ping session here. So back to Mininet. Ping all. Ping all is a great command that lets you ping from every host to every other host. Here we only have 2, and you can see them successfully ping one another. iPerf. iPerf is installed as well, so I can see TCP and UDP bandwidth between my hosts. If we just type iPerf, we get TCP bandwidth between H1 and H2. You can see it takes just a moment to complete the test. And we see I got 214 megabits per second. I could also do iPerf UDP, and that would give me UDP bandwidth. Okay, so let's exit out of Mininet to show how you can introduce latency in your network links. This is a new feature starting with Mininet version 2.0. So I just exited out. And by the way, here is a good time to recommend that whenever you end Mininet, especially if Mininet ends abruptly, it's probably a good idea to run sudo mininet-c. This will do a cleanup. For example, it'll kill any zombie processes that would prevent a clean new run of the Mininet topology. So here's an example of introducing latency in all your links. So I'll run sudo mn --link tc, bw equals 10, so I want my links to have a bandwidth of 10 megabits per second and delay of 10 milliseconds. So we see it start here, and as expected we see our links are 10 megabits per second, and we've introduced an artificial delay of 10 milliseconds each way. If I run iPerf again, we see versus last time we should get a much lower throughput for TCP here, and I only get around 9.5 megabits per second. Let's look at Wireshark. Wireshark is built into this VM as well. To launch it, I'll use a second SSH session into my Mininet VM for my laptop. And again, I can't forget to enable X11 forwarding so that this works. Password of Mininet again. And I'll run sudo wireshark ampersand so it runs as a background process. And I'll start my capture, and I'm going to do my capture on interface loopback 0. In this Mininet topology, the SDN controller is local, so it and the OpenFlow switch talk over our VM's loopback 0 interface. So that's why I'm capturing on that interface. And I'll filter just for OpenFlow, just so we can see OpenFlow packets. And there we go, we can see OpenFlow message right here. Right now we just see some echo requests and replies between the controller and the switch. So let's do a ping all command again and see if we can get some more interesting packets. So I'll do ping all, and I'll jump back to my Wireshark capture, and let's stop it. And here we see some OpenFlow protocol packets. Here we see some packet in messages from the OpenFlow enabled switch up to the controller, and we see some flow modification messages from the controller back to the switch. The first time I ever saw an OpenFlow packet in action was right here. This is a great way to learn about OpenFlow and troubleshoot any work you're doing with OpenFlow. In another video, I'll talk specifically about these messages and OpenFlow using Mininet. Okay, so as I mentioned before, there are a lot of other topologies you can run for Mininet. Here are a few others that are available from the command line. Single. So if I do sudo mininet -- topo -single, 4. Here we have the same basic topology as before with a single switch, but now there are 4 hosts instead of 2. So that's going to look something like this. Linear. Here's the linear topology. Instead of single here, I'm going to say linear and 4 again. And we see what that will look like here. There's our 4 switches and 4 singly attached hosts to each switch. Tree. Here's a tree topology. And I'm going to say 2 levels deep and a fan out of 2. And that's going to look like this here. So we have 2 levels of switches and a fan out of 2, meaning I split just into 2 switches here at my second level. We can make this topology much larger, but I'm just showing a smaller example of the tree topology. Totally custom topologies are also available if you use the Mininet Python API. Details of this are on mininet.org. So that's some of the basics of Mininet. In future videos we will use Mininet to look at more detail into OpenFlow and at running different SDN controllers. I hope this video was helpful. If you'd like to reach me, I can be found at LinkedIn at linkedin.com/David Mahler.